Okay guys, so here we go to one more video. First of all, I want to show you guys the new Facebook group I created for everyone in the videos. It's called Algorithms Ninjas. If you wanna become a ninja in algorithms, join this group. Let me turn it up a little bit to make it more exciting. So algorithms ninjas, just join the group, leave in the comments that you're willing to join the group and let's do it together. I hope you guys can stick to video number 100. So let's go to longest palindromes. 401. Given a string which consists of lowercase or uppercase letters, find the length of the longest palindromes that can be built with those letters. So what is a palindrome? A palindrome is a word that can be read from both from left to right and from right to left, and they are pretty much the same. So here you have DCCACCD. It's the same word regardless of the order you read it, right? And that's what we want. We want the longest sequence of letters that give us a palindrome. I thought about this problem for a while. I tried over and over again and I still couldn't solve it. So I asked for help. Raquel, a big shout out for you for helping me with this problem. And I'm gonna explain to you the approach. It might be confusing, but if you guys try it out by yourselves, you understand that it's the most efficient one. So what we're gonna do is forever we're gonna count the letters available to us. So for example, here you have three A's, three B's, four C's, and one D, and we're gonna count how many of those letters we have. And that's what we're doing with this line of code here. Collections.counter with S. S is the string. It will give us a dictionary counting how many letters we have in the string. And now I want to convince you uh, about certain facts that will help us solve the problem. The first fact is if we have an even count of a certain letter, we're gonna add that letter to our count. What does that mean? So we have four C's. With four C's, we can beat a palindrome, right? We just, for example, four A's is a palindrome by itself. So every time we have an even count of a certain letter, we're gonna add it to our total. So total equals 4. Suppose we have 3. Not necessarily we can build a palindrome with C. If we add it here, it's gonna be a palindrome, but if we had, for example, if we had other odd number, for example, 3 C's, we wouldn't be able to build a palindrome. So the next step might be some sort of sorcery, but you guys are gonna see that it's gonna work. So if we have an odd number of a certain letter, so for example, I call this function with here. We have 3 A's, 3 B's, and 1 D. We're gonna subtract 1. We're gonna subtract 1 for each odd count letter, and we're gonna add it to our total. So A, we have 2. So we're gonna leave out one letter. B, we have 2, 3 minus 1. And 1, we're gonna add 0, 1 minus 1. Right? So we just got, so again, C is even, so I'm gonna add to the total. A is 3, I'm gonna subtract 1. B is 3, I'm gonna subtract 1. D is 1, I'm gonna subtract 1. Why am I doing this? Because in this case, I have I have 4 A's, 4 A's. Is it 4? Yeah, no, 3 A's, sorry. I have 4 C's. I have 4 C's, 4, 3 A's, 3 B's. I'm gonna convince you guys that this will be a palindrome. So if I get 4 C's, 2 A's, 2 B's, I can build a palindrome. So this is a palindrome, right? I left out one B, I left out one A, and I could build a palindrome. But we still have room for one word, one that will fit here right in the middle. It can be any word, it could be like X, Y. So we can fit one more letter. Whenever we have an odd number of letters, we're gonna get one and add it, because we still have room here, right? So in this case, we left out 1A, we left out 1B, and we left out D, because we subtracted one for them, right? So we can pick one of those and add it to the middle. Add it here. And whatever letter you pick, it's not gonna really matter. What matters is that you added one. So here you're gonna add one. Let me turn it down a little bit. So that's what. Oops. Where am I? That's what I'm gonna do. That's what I'm gonna do here. So first we count the letters in the string. So in this string in particular, that's the one I'm sending. I have 4 C's, 3 A's, 3 B's, and D1. Then I'm gonna sum how many odd. So this is iterating over the values, iterating over 4, 3, 3, 1. I'm gonna bitwise it with 1. When you bitwise something with 1, if it's true, it means it's odd. If it's false, it means it's even. So here we're gonna count, it's gonna sum how many odd number counts I have in the string. And we have 3. We have 3 because we have A with 3, B with 3, and D with 1. So we have 3 letters with an odd count in the string. And we're gonna verify if there are odds. Why are we verifying if there are odds? If there are odds, we're gonna add 1 in the end. That's one letter we fit in the middle. If not, we don't. And that's what we do here. So we're gonna get the length, the total length of the string. We're gonna subtract by how many odds count letters we have. So for example, we have 3. We're gonna subtract 3, 1 for each one. So -1, -1, -1. So -3. That's what we're doing here. And we're gonna add 1 in case we have odd numbers, an odd count of letters in our string, because that's the letter we're fitting in the middle. We're fitting, for example, C. So if we run this, it's gonna work. It's gonna work. It's 9. We have 9. That's the size of the maximum palindrome. And this is pretty confusing. I'm not gonna lie, it took me some time to understand what the problem was about, how to solve it. So if you don't understand, try to go over the video again, ask me questions. Asking questions is so important. I only understood this problem because I asked questions to Raquel, who's watching the video right now. Thanks a lot for the help. So now let's put it here. We're gonna put it here. So we're counting how many odds we have. And we're gonna do everything in one line. So here, we're gonna return the length of S minus odds. So we're subtracting 1 from each odd count letter. I know it sounds confusing, but go over the video again. And then we're gonna sum 1, just because we can fit 1 in the middle. So if we do have odd count letters, we're gonna sum 1 in the end to fit 1. So let's submit, and we got accepted. So this line is a bit confusing, I know. You're just checking if it's odd. You're iterating over the values of the table, you're summing. What this whole thing is doing is just counting how many odd count letters there are in the string. And then we did that algorithm I said. You subtract one for every odd count letter, and then add one in the end to fit the letter in the middle. Kind of confusing, so practice and ask questions. So once again, if you want to join the Facebook group, just give me a shout out, and I'm pretty excited to meet you guys. So thanks for the thanks for being part of the ninjas in algorithms.